This is the third theory session of the problem-solving test course, and it is devoted to fact questions. I will explain what questions fall into this category. After that, we'll discuss an algorithm to solve fact questions as quickly as possible, but not too quickly, to avoid some unnecessary and stupid mistakes. And after that, we'll look at several examples.
Recall that there are four major question types: premise, fact, conclusion, and the last 13%. Today we are talking about the second type, fact. Fact questions fall into four subtypes. 1. Estimation. Simple calculations which do not require precision. 2. Precise computation. Simple yet time-consuming calculations or calculations requiring high precision. 3. Word problem. Build an equation or formula based on the data in the text and exhibits, then solve or compute it. 4. Ranking. Rank several options by their values. Recall the differences among question types. A premise does not have to be true or based on the data in the text or exhibits. It might be a completely new piece of information. However, if we assume its truth, it allows us to make certain conclusions about a fact stated in the text. In comparison, a fact is true based on the data. You just need to interpret it. And a conclusion has to follow from the data. Let us look at an example of a fact question. What is the average productivity of all workers in Table 1? First of all, what is productivity? Productivity is output divided by input, right? Output is items made, while input is hours spent. Now we need average productivity. In PST, that means we need to sum up all outputs and divide by all inputs. Worker by worker division is not necessary. It would take just too much time. Then the answer is just 100 over 130. Time to do some calculations, right? Oh, wait a sec. Can we approximate here? The answer options are far apart. 100 over 130 is definitely less than 1. That means options C and D are out. But similarly, 100 over 130 is definitely more than a half. So A is out. So our answer is B, and we do not need to be any more precise than that. The algorithm we will use for solving questions of fact type has 4 steps. Understand the question, get the data, try to find a quick solution, and go for a complete solution if absolutely necessary. At the first step, we need to understand what question we have to answer. The tricks of most questions lie in details rather than computational complexity. So pay attention to the details, subjects and their actions, numbers, references, and directions. In the meanwhile, notice the range of answer options. Is it wide or narrow? If it is wide, most likely you can solve the question easily by quick approximations. If it is narrow, however, you will need to invest more time in the question. This knowledge matters for time management, especially at the end of the test. At the second step of the algorithm, we need to collect all the data necessary for solving the question. The most important part of exhibits are title, exhibit type, legend, units of measurement, and references to other exhibits. The text usually provides useful information on the variables, including their definitions and sometimes values. As an example, let us read an exhibit from an official McKinsey PST. Here it is. First thing we notice is the title of the exhibit, Housing Starts by Quarter. Then the legend explains that 3 different lines are 3 possible scenarios for the dynamics of housing starts. Then we check the axis. Horizontal axis depicts the timeline in years, while the vertical axis shows the numbers of housing starts. At this point, we might wonder what a housing start is, so we go back to the text and search for a definition of the term. Additionally, we discover that vertical lines are first quarters. This is clear from the exhibit itself, but our understanding is now confirmed. Once we've analyzed the data, we are ready for the third step, search for a quick solution. The 2 major pieces of advice here are estimate and eliminate. Estimate means be lazy about computations. Figure out what needs to be calculated and search for approximations and roundabouts. Round numbers as much as possible, but not too much to avoid mixing of options. Eliminate means test options and get rid of obviously wrong ones, those which are too large or too small. Drawing values, for example averages, on exhibits might also help eliminate some options. Let's have a look at an example. You might want to pause the video here to try and solve the question on your own. In this question, we need to increase the share of left-handed employees at GNP, the first column, so that the corresponding absolute value reaches that for RAMs, the second column. Notice that the options are quite far apart, which is great for us. We can approximate. To find the percentage increase, we need to calculate the number of left-handed employees at each company, take the difference, and translate it into percentage points. The number of left-handed employees at GNP is 9K times 30% equals 2.7K. The number of left-handed employees at RAMS is 12K times 60% equals 7.2K. At this point, we could dive into calculation of 7.2K minus 2.7K over 9K. This solution is correct, but can we find a quick alternative? Yes, if we use elimination. Notice that we need to more than double the number of left-handed employees at GNP to reach the level of RAMs. That means the difference will be more than 30 percentage points, because the current share of left-handed employees at GNP is exactly 30%. So options A and B are wrong, they're just too small. But the option D is too large. 30% plus 70% equals 100%. So in this option, all of GNP's 9K employees have to be left-handed, which is an overkill. So option D is wrong too. So the only plausible option here is C. In this way, we found a quick solution and avoided straightforward calculations due to eliminating answer options. Another opportunity to practice quick solutions is this ranking exercise. We need to order 5 companies according to their profits, revenue times profit margin, from largest to smallest. Again, you might want to pause the video here to try and solve the question on your own. This straightforward approach is to calculate all profits, then order them from largest to smallest, then look at the answer options and see which fits best. A quick approach is to look at the options, understand which pairwise comparisons we need, do them, and eliminate all but one option. Notice that options A and D rank company 2 above company 1, while options B and C do the opposite. Both cannot be correct. If we compare 1 to 2 and learn which is bigger, we can get rid of 2 options. 15% of almost 400,000 is more than 10% of less than 600,000. So profit of company 2 is larger than profit of company 1, and options B and C are out. What we need to compare next is options A and D. Similarly, compare profit of company 3 to profit of company 4 and find that the former is greater than the latter. So D is out. And our answer is A. In some cases, unfortunately, a quick solution won't do, or just won't be enough. Then we'll have to take the 4th step, complete solution. Instead of jumping at the numbers randomly, we need to figure out our strategy first and only then execute it. Start with a generic formula or equation like revenues equals cost plus profit. Then add details, replacing, for example, revenues with price times quantity and costs with the sum of variable and fixed cost. At this point, we might want to work with letters P, Q, R, and so on, rather than numbers. Observe which quantities are known from the data and, if needed, select the most convenient variable for the unknown. You get a pretty detailed formula or equation. Now it's high time for execution. Insert numbers, simplify, and solve for the unknown. Finally, the transition from the unknown value to the value asked in the question is critical. We might have chosen monthly revenues as X, but the question asks for annual revenues. Then the answer is 12X rather than just X. Most questions try to catch us off guard on this trick, so be careful. To test the approach, let us tackle an example similar to what we've solved before, the RAMS and GNP story. However, this time the numbers are a bit more complicated, while the answer options are too similar for quick approximations. We have to be more careful now. You might want to pause the video here to try and solve the question on your own. Let us figure out the strategy first. Just like before, we need to compute the number of left-handed employees at GNP, the number of left-handed employees at RAMS, take the difference, and divide it by the number of employees at GNP. In the question before, we did not pay much attention to it. The answer is, this time the calculations will be more time-consuming, and we cannot afford to go in the wrong direction. Now, execute computations. Notice that even in situation of seemingly precise computations, there might be some room for approximations, but these approximations have to be more precise than in the estimation case. This is how I would do the calculations. If this technique is not familiar to you, I suggest you read a book on mental math. Our consulting math course book covers this topic extensively too. So the answer is B, because A is too small, while C and D are too large. And here's a word problem example. Find the size of the combined air fleet of two hypothetical states. You might want to pause the video here to try and solve the question on your own. The problem might sound daunting at first, but it becomes much easier to solve once we tackle it step by step. Strategy. Let's find a generic equation first. What remains unchanged in the setting of the question? The number of helicopters, expressed separately and simultaneously for the two states. Insert the data from the problem to make the equation more specific. Helicopters make up 95% of the fleet of North Dakota, 86% of the fleet of South Dakota, and 100 minus 10 equals 90% of the combined fleet. The combined fleet can be expressed via the fleet of just one state. Let's write it down. The most convenient unknown here would be Ni, the size of the air fleet of North Dakota. Notice that this variable is not what is being asked in the question, but it will help us find the answer. Okay, now time to solve this equation. Simplify, solve, and find the unknown. And then find the desired value, the size of the combined fleet. The answer is D. Well, that wasn't too quick, of course, but not rocket science either, right? Let us synthesize what we have learned today. A fact is just what we get from the data. It is true by definition. We just need to get the right data and tweak and mix it in the right way to establish this fact. The way we do this tweaking and mixing is via 4 steps. 1. Understand the question and find keywords. 2. Get the data from exhibits and text. 3. Try to solve quickly through estimation and elimination. And 4, if necessary, build a complete solution, defining your strategy and carefully executing on it. That's all for today. If you have any questions, as always, feel free to leave comments below. Thanks for watching and see you next time.